But here's the good news. I don't think anything today is new material. This is all stuff that we've done before. Right, so first off, this rule. Sarah mentioned it just a little bit ago, right? So this is the nth root of the numerator, right? X over the nth root of the denominator, y. Dividing radicals. We've done it already. We've even done it this year some. So you got the nth root of x over the nth root of y. If you can reduce your radicand, you can do that. Sometimes it's to your advantage, sometimes it's not. You just have to look. So in this first one, it's just the square root of 4 over the square root of 49, right? Pretty simplistic. And this is a 2/7. Nothing earth-shattering there. You're able to split it up. So the second one, just be careful because you're looking at a cube root. So you got the cube root of 8x to the 5th over the cube root of y to the 6th. Okay, are you good enough to know the cube root of 8 is 2, right? After you see that one a bunch of times, hopefully that gets to be automatic. And again, when you look at an x to the 5th, you have to be thinking, all right, I can take the cube root of 3 of those x to the 5ths. And the cube root of 3 of those x to the 5ths, or that x cubed, is an x. And I used up 3 of them, and there's 2 of them left in there, right? And that's all you're doing on the simplified aspect. And then the bottom, y to the 6th, 6 divided by 3 is 2. It's y squared, right? That one was fine. It was ready to go because you can divide the 6 by the 3. So cube root of the top divided by the cube root of the bottom, and that's all you're going to do with those. All right. So then if you'll remember, you can't have a radical in the denominator. So the bottom of fraction cannot remain as a radical. Does anybody remember what it's called? Rationalize. All right, good. Remember that? Rationalize the denominator. R-A-T, rational, R-A-T-I, rationalize. Beautiful. R-A-T-I-O-N-A-L-I-Z-E, I guess. Rationalize the denominator. Rationalize the denominator. For cube roots, just be careful. You need 3 of each factor. And this is what trips you up. It's what tripped you up in algebra. So don't let it trip you up in algebra 2. If you have a cube root, you need 3 of the factors instead of 2. Square root, you only need 2. You're still going to rationalize. All right, so let's go through a progression. I'm trying to take you to a spot where it makes sense. So the first one, look, it's algebra 2. What's the square root of 121? 11. All right, so we can put the 11 on the top, right? But the bottom's got to stay square root of 7 for now. Right? I did the rule in my head, square root of the top over the square root of the bottom. And now you got to rationalize the denominator, right? So hopefully you agree you're going to multiply that bottom by the square root of 7. What are you after? You're taking a square root and you need 2 7s to take the square root. You already have 1. So you're going to supply the second one. Whatever you do to the bottom, you're going to do the same thing to the top, right? Top ends up 11 times the square root of 7. And the bottom, square root of 7 times the square root of 7 is 7. So let me just pause for a second and remind you of something. If the 11 would happen to reduce with the 7, you could do that. It doesn't, but if it did, you could and you should. However, don't be doing this 7 and that 7 because the top 7's part of the radicand. It's the radicand. It's under the radical sign. You can't do anything there. All right, so that's that one. Second one is similar, only the top has to stay square root of 2, right? And the bottom is the square root of 7n. So again, all you're worried about right now is I keep using green. All you're worried about right now is the bottom. So how many 7s do you need? 2. How many do you have? 1. So supply the second 7. How many n's do you need? 2, because the index is 2. How many n's do you have? 1. So supply the second n. Whatever you do to the bottom, do the same thing to the top. Again, the bottom is where you're looking, because the bottom is where the issue is. The bottom is where you can't have a radical. So now we've already multiplied radicals, so we know the top is the square root of 14n. Though, by the way, I am looking at those numbers and making sure now all of a sudden something doesn't simplify, right? Because it might. The bottom, 7 times 7, the square root of 7 times 7 is 7, the square root of n times n is n, or you could think of it as the square root of 7n times the square root of 7n is 7n. You think they're the same way. All right? All right, keep going in progression. Now let's do some cube roots. So we got to leave the cube root of 4 in the top because you can't take the cube root of 4. We have 2 2's, we need 3 of them. And the bottom is the cube root of 5. So now I want to use green. So again, where are you looking? The bottom. Bottom is where our concern is. How many 5's do we need to take the cube root? 3. How many do we have? 1. So we need 2 more. We have to supply the other 2 5's because it's a cube root, not a square root. You need 3 of them. And again, you're looking on the bottom first. Whatever you do to the bottom, same thing at the top. Now, when you finish this thing off, again, I'm looking at the cube root of 4 and then 2 5's, and nothing will simplify there, but I am looking before I multiply everything out. Because once you multiply out the numbers, you'd have to unmultiply them to figure out if you can simplify. So look now. So what is that? 4 times 25. That's the cube root of 100. And what's the cube root of 5 times 5 squared? 5. All right. That should be like half a second thought. What are you after? So again, if you're not just writing and you're thinking what we're doing, what are we trying to get? 3 5's in the bottom so we can take the cube root of the 5 cubed. And what is it? 5. Again, that's what it's all about. That's what you're after. So the next one, you got the cube root of 3 in the numerator. And you got the cube root of 2x squared in the denominator. So I'm going to pause. Why don't you go ahead and rationalize that one? All right, so on 3, give me your answer. 1, 2, 3. Okay, close, some of them. Cube root of 12x over 2x. Because 2 squared, I need 2 more 2's, right? I only have 1 2. I need 3 2's. So I got to do 2 more. I already had 2 x's, so I only need 1 more x. So 3 times 4 is 12 on the top. So you got the cube root of 12x on the top and 2x on the bottom, right? No reducing because you got radicand and non-radicand. How many got that right? Okay. And the rest of you know what you did wrong? So again, remember, it's all about the index. Cube root, you need 3 of things to take the cube root. Square root, you need 2. That's not really a hard concept. I know students balk at that because you're just a little unsure of yourself, but square roots, you need 2 of them, and cube roots, you need 3. Okay, so let's keep going here. Cube root of negative 27. Can you do that one in your head? Negative 3, right? Cube roots can be negative because negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. All right, on the bottom here, we got the cube root of 20n. You could go the quick route here, but I wouldn't advise it because it's really the long route. And you could rationalize with the cube root of 20 squared n squared. But if you do that, you are definitely going to be simplifying your numerator. And you're going to be reducing because you're going too much. You really got to look at this 20 and look at it as a 4 times 5 and realize that the 4 is a 2 squared. Because if you don't do that, you're going to leave your answer unsimplified. It'll be true what you're doing, but it's not the most efficient way. So now when I rationalize, again, my index is 3, so I know I need 3 of stuff. I have 2 2s, I need a third. I have 1 5, I need 2 more. I have 1 n, I need 2 more. Does that make sense? Right? Again, we're trying to get 3 of every factor because that's what we can take the cube root of. And again, whatever I do the bottom, I'll do the same thing to the top. Now the top, again, I could write it out now. I don't need to write 2 times 5 squared, or you can, but that's what, 50 n squared? Because I'm looking and there's no simplifying of that in the top. Now again, you can write 2 times 5 squared. So what is your top? A negative 3 times the cube root of 50n squared. And what is your bottom? You're going to get a 2 out, you're going to get a 5 out, and you're going to get an n out, right? Now my top has a negative 3, my bottom has a 2 times 5, so that doesn't reduce, but if that top would have been a 2, it would have. Or if that top would have had a 5, it would have. So your final answer is what? Negative 3 times the cube root of 50n squared over 10n. Okay, real quick, let me remind you on imaginaries. So do you agree that the bottom is, so for f, what's the bottom? 3i, right? So what is an I? Square root of negative 1, right? Oh, so we have really technically a radical in the denominator. That's no good. So we got to get rid of that radical in the denominator. So we got to rationalize. So what are we going to multiply this thing by? By I. Why do I want I squared in the bottom? Because I squared is a negative 1, right? All right, good. Whatever you do at the bottom, do the same thing at the top. So now the top is 2 times I is 2i, better than 4 i's. And the bottom is 3i squared. But remember, you did this because an I squared is a negative 1. Are you going to leave your negative in the bottom? Another just simplification issue. Put the negative in the top. You now have negative 2i in the top over 3, right? And it's a negative 2/3 I or a negative 2i over 3. So for time's sake, I'm not going to do G, but hey, G is definitely one that reduces, right? That's a 2 times 5, and that's a 2 times 6. So you got 5 in the top, 6 in the bottom. You know what? I better do it. Because this square root of negative 5 is an I times the square root of 5, right? Hopefully that's not earth-shattering, right? So what would I rationalize with on the bottom? What do you need to take care of the I? You need another I. What do you need to take care of the square root of 5? Square root of 5. So just take care of what you need to take care of, right? So you need an I times the square root of 5 on the bottom. Whatever you do at the bottom, do the same thing at the top. Now this thing's going to end up with another 5 on the bottom that will reduce with the 5 on the top. Do you agree? I better do it. So the top, right, is 5i times the square root of 5. That's pretty straightforward. You still have the 6 on the bottom. Now you have I squared on the bottom. And the square root of 5 times the square root of 5 is 5. So that's what I was talking about. Those 5s divide out. You can divide out those 5s, and you got to take care of that I squared, which is a negative 1. Final answer. Negative the square root of 5 is the top, right? I put the negative in the top, and the bottom is 6. Because again, The I squared is negative 1. And I'm missing my I. Thank you. No Kool-Aid for you. Negative I times the square root of 5 over 6. Gotta be thinking. Okay, so we did this as well already. Remember, binomial radicals in the denominator, you got to rationalize the denominator by multiplying by the, anybody remember the term? Multiply by the, you're after getting a difference of two squares, which means you got to multiply by the conjugate. You got to multiply by the conjugate. In Algebra 1, I took time and showed you that multiplying the bottom by the square root of 3 won't work. I don't have the time to do that right now. But look, put that in a parentheses, treat it as a binomial, because that's what it is. And we all know now what the conjugate is, the exact same thing with the different sign in the middle, right? We just made a difference of two squares. Whatever you do to the bottom, do the same thing to the top. Right? I always deal with the bottoms first because I really want to see what numbers I have because it might reduce with something on the top. All right, difference of two squares. We can do the shortcut, right? Front times front. Square root of 3 times square root of 3 is 3. Back times back. Do it in blue. Square root of 1 times 1 is negative, or negative 1, I'm sorry, times 1 is negative 1. So our bottom is a 2. We have a 7 in the top. If we had a 6 or a 2 or an 8 or a 10, I'd be reducing with that top before distributing. Just going to save me time. This one doesn't. So distribute the 7. 7 times the square root of 3 is 7 times the square root of 3. 7 times a 1 is a positive 7, right? You're distributing. It's a number times a binomial, and the bottom is 2. And that's it. We don't have time to finish B, but you know what you'd multiply by, right? Square root of 3 minus square root of 2. Square root of 3 minus square root of 2. C, what would you multiply the bottom by? Just say it on C. Square root of 2 plus 5. Hey guys, let me just remind you of something on C. You can't do this 5 and this 5. What I try to get you to remember is they're tied together by addition. The top 5 is tied to this square root of 5 by addition. And the bottom, negative 5, is tied into the square root of 2 by addition. You have to take them as a whole quantity. You can't reduce them. And that's somewhere where students get in trouble. They'll try to like cross out those 5s, and you can't do that. Okay? You can do a whole quantity, but you can't do part of things being added. All right, let's do the last one. Let's do the last one. What do we got? 2 to the 1/4. You could treat this a couple different ways. You could treat this as a radical and then do it as a radical, or you could treat it as an exponent and do it as an exponent. Let's treat it as an exponent. So technically, a fractional exponent is the same as a radical, is it not? Isn't that the same as the 4th root of 2 on the bottom? So, let me show you both ways, because maybe for some of you, it'll be easier doing it this way. Right? Those are the same. 7 over 2 to the 1/4 or 7 over the 4th root of 2. Again, what's the key rule so far this chapter? The b root of the square root of x to the a equals x to the a over b. Again, that's why on the front of the quiz, if you miss that rule, I mean, you use that rule all the time. Okay, so on this one, I need to get rid of the fraction. Now remember, x to the a times x to the b equals x to the plus b. So I'm adding exponents. So though I have a 2 for a base, what do I need to add to a 1/4 to get it to be a whole number? 3/4. I need a 3/4. Whatever I do to the bottom, do the same thing to the top. So where do you end up on the left? 7 times 2 to the 3/4 over, and let me show you this step, 2 to the 1/4 plus 3/4, which is 2 to the 1st, right, or 2. Don't try to reduce a 2 to the 3/4 with a 2, all right? Doesn't work. And don't do the rule x to the a divided by x to the b equals x to the a minus b, because then you're going to end up with a negative exponent, and that's another thing we don't want, right? At an end result, we don't want negative exponents. So that's the answer this way. I don't kind of like that answer, but it is an answer. So if you had the 4th root of 2, you'd have to multiply that bottom by the 4th root of 2 cubed, right? Because how many 2's do you need? You need 4 of them, right? It's a 4th root. I only have 1. I need 3 more 2's. Whatever you do to the bottom, do the same thing to the top. So in this one, you get a 7. Would you leave it 2 cubed? You'd make that an 8, right? And what's the bottom? 2. And those are the exact same answer. One's in radical form, and the front is in fractional exponent form. But it's the same answer. Which one's better? Depends on who you ask. I think the right one is better, but it depends on who you ask. If the directions say leave it with a fractional exponent, then you got to do it on the left. If it doesn't say, it would be your choice. All right, videos on HCS math class if you need it. I wish I had time to review. I don't.